Hey everyone, and welcome back to Talk Tensors. We're diving into a really interesting paper today.
Oh, yeah.
It's called Cross-Decon V, Cross-Dimensional Transferable Knowledge Base via Fourier Shifting Operation.
Okay.
And basically, it's all about using 2D images to help us understand 3D images,
Interesting.
actually in medical imaging.
Yeah, that's a problem that's been around for a while. We have so many 2D images like x-rays, but when it comes to like really diagnosing and treating people, 3D images from MRI or CT scans,
Right.
they give you a much clearer picture.
Yeah, it's like the difference between looking at a map and like actually walking through the terrain in 3D.
Exactly.
Like you get so much more information
You do.
when you can see it in 3D.
Absolutely.
But the problem is that 3D data sets are just so much smaller
Yes.
compared to the 2D data set.
And more complex.
Right, more complex.
Yes.
So how do we bridge that gap?
Well, that's exactly what this paper is trying to solve.
Okay.
They introduced this concept of a cross-dimensional convolution, or Cross-Decon for short.
Okay.
And it basically acts as a bridge between 2D and 3D convolutional operations.
I'm intrigued. How does it actually work? Is it like magic?
Well, it uses some math,
Okay.
a little bit of mathematical wizardry.
Okay.
It uses something called a Fourier Shifting Operation.
Okay.
It's a little technical, but imagine taking a 3D image
Okay.
and rotating it in space.
Hmm.
You get different 2D projections, right?
Right.
So Cross-Decon uses a similar idea by like manipulating these things called convolutional kernels,
Uh-huh.
which are basically filters that extract features from the image, and it does that by shifting their phases
Right.
in the Fourier domain.
Okay.
So essentially this allows the model to kind of like see connections between 2D and 3D features.
That's really cool.
Yeah, it's pretty neat.
It's like teaching the computer to translate between 2D and 3D.
Exactly.
I'm curious, like, what led to this breakthrough? Was it just like a sudden eureka moment, or was there some like previous work that led up to this?
Yeah, it's definitely not just a sudden thing.
Okay.
To really understand like how novel Cross-Decon is,
Mm-hmm.
we need to look at the history of computer vision.
Okay.
So for a long time, computer vision was all about 2D
Okay.
because 2D images are easier to work with and there's lots of data.
Mm-hmm.
But then, technology advanced, especially in the medical field, and 3D imaging became super important.
Right, because we're 3D.
Exactly.
So our organs and tissues are all 3D.
Exactly. We're not just flat surfaces.
Right.
So then the challenge became, how do you analyze these like really complex 3D images, especially when you don't have that much data to train your models?
Right.
Yeah, and that's where this idea of transfer learning came in. So it's like, we've learned a lot about 2D images.
Mm-hmm.
Can we use that to learn about 3D images?
I see. It's like learning to ride a bike. Like the skills that you learn from that, like balance and coordination.
Yeah,
You can kind of apply that to like snowboarding,
that's a great analogy.
even though it's like a totally different thing.
Yeah, it is a different thing, but it uses some similar skills.
Right.
So there were some earlier attempts to bridge that gap between 2D and 3D.
Okay.
One was this thing called ACS-Con,
Well,
and they tried to adapt like existing 2D architectures to analyze 3D stuff.
so it's like trying to fit a square peg in a round hole.
Pretty much, yeah. It wasn't the best solution,
Yeah.
and that's where Cross-Decon comes in with this much more like elegant and dynamic approach.
Okay.
So it uses this special module that manipulates the weights of convolutional kernels, and it does that using a combination of rotations and Fourier transformations.
Okay, hold on. Rotations and Fourier transformations.
Yeah.
Could you break those down a little bit for me?
Sure. So imagine you have like a 2D image of a cube.
Okay.
If you rotate that cube in 3D space, you get different 2D projections, right?
Right.
So Cross-Decon V uses rotations to create these different 2D views
From a 3D image.
from a 3D kernel.
3D kernel.
Okay, so we're taking that 3D object, rotating it.
Okay, and looking at the 2D projections.
Okay, what about this Fourier transformation?
Yeah, so the Fourier transformation is used to handle the complexity of those rotations, but in a more computationally efficient way.
Okay.
Think of it like breaking down a complex sound into its individual frequencies.
Okay.
That's what the Fourier transform does, but with images,
Okay.
breaks them down into their spatial frequencies.
So instead of physically rotating the 3D object,
Right.
which would take a lot of computing power,
Exactly.
they're manipulating its frequency representation.
Exactly.
That's really clever. But did they actually prove that this whole Cross-Decon V thing actually works?
They did. They put it to the test,
Okay.
and the results are pretty impressive.
Uh-huh.
So they used both natural images and medical images.
Okay.
So for the natural images, they used ImageNet.
Oh, yeah, I've heard of that one.
And for the medical images, they used this thing called RadImageNet.
RadImageNet, okay.
And to test it out, they used a popular architecture called ResNet 18. ResNet 18. Okay. I think I remember that from like one of our earlier deep dives.
Yeah, it's a convolutional neural network.
Right.
So why ResNet 18?
Yeah, why that one specifically?
Well, it's known for being both efficient and effective for image analysis.
Okay.
It also has like these modern features that are really important for testing out something like Cross-Decon.
All right.
And guess what?
Right.
Cross-Decon achieved comparable or even better performance than more traditional methods.
Wow. So it actually works?
It does. It actually works.
That's awesome.
It's pretty cool.
What kind of tasks did they test it on?
All sorts of things. Image classification and feature quality assessment.
Okay.
It was really good at assessing the quality of the features.
No interest.
So basically, it could pull out more meaningful information from those images, which is really important.
So it's like a really good detective who can pick out like the subtle details that like normal people would miss.
Exactly.
Especially for medical images where those tiny details are super important.
They are.
So you mentioned that they used a bunch of other data sets too, not just ImageNet and RadImageNet.
Yeah, they really wanted to make sure that this method was robust and could be applied to all different kinds of medical images.
Okay.
So they used CT scans, MRI scans, ultrasound images, even data sets related to COVID-19 diagnosis.
Wow. So it really could be used for all different areas.
Yeah, exactly. It has the potential to be used across so many different specialties.
That's really exciting.
It is.
Well, I think it's time for our Novel Notion segment.
Yes, let's get creative.
So what kind of future possibilities does Cross-Decon open up?
Ooh, lots of things.
Okay.
So one thing I was thinking about was, what if we could extend this beyond single modalities?
What do you mean?
Like right now, they just tested it on like MRI or CT.
Right.
What if we could use it to transfer knowledge between different imaging modalities?
So like using information from a chest x-ray,
yes,
which is 2D, to improve the analysis of a 3D lung CT scan.
exactly.
That would be huge.
It would be really helpful in cases where getting a 3D scan is difficult or risky for the patient. So it's like the model can connect the dots between different pieces of visual information.
Yeah, and give us a more complete picture
Exactly.
of what's going on.
Yeah.
That's really cool. Do you have any other ideas?
I do. How about real-time 3D imaging analysis?
Oh.
So imagine a surgeon performing a surgery,
Okay.
and they have access to real-time analysis of 3D medical images.
Wow.
That would be amazing.
It's like having an AI assistant
Yes.
right there in the operating room.
It could provide them with instant feedback and guidance.
It could revolutionize surgery.
It really could.
Oh,
And that's just the beginning. There's so many potential applications.
that's amazing.
We could have earlier and more accurate diagnoses, personalized treatment plans, even new drug discoveries.
It's really exciting stuff, but we have to remember that it's still early days.
Oh, absolutely. We need a lot more research
Right.
before any of this becomes a reality.
But it's exciting to think about.
It is. It shows how powerful AI can be
Yeah.
and how it could transform healthcare.
It's mind-blowing, really, when you think about all the possibilities.
It is.
But I think it's important to bring it back down to earth for a second
Okay.
and talk about like the practical implications of
Right.
Cross-Decon,
Yes.
especially for medical imaging.
Absolutely. Because at the end of the day, what matters is how this technology can actually help people.
Right, exactly.
So one of the most promising things about Cross-Decon is that it could make diagnoses more accurate.
Okay.
Like imagine being able to spot something in a medical image that a human doctor might miss.
That would be amazing.
It would, because catching things early is so important for treatment.
Right.
So Cross-Decon could really help with that.
It's like having a second opinion from an AI.
Yeah, and one that's been trained on way more data than any human doctor could ever see.
Right, and can spot patterns that we might not even know exist.
Exactly.
But it's not just about finding those abnormalities, right?
No, it's not.
It can also help us understand how diseases progress
Yes,
and whether treatments are working.
exactly. By looking at those 3D images over time, we can really track how things are changing.
So it's like a dynamic view
Yeah,
of what's happening inside the body.
it is. It's not just a snapshot.
And we talked about how computationally efficient it is, too.
We did.
And that's super important in medicine because time is critical.
It is. You don't always have time to wait for those big 3D data sets to process.
Right.
But with Cross-Decon, we can use those 2D images that are already out there
Right.
and get answers much faster.
So faster diagnoses, faster treatment decisions,
Yes,
and hopefully better outcomes for patients.
absolutely.
Wow. It's incredible to see how everything comes together.
It is.
The technical details,
Yes.
the historical context, the potential.
Yeah, this paper really highlights how fast AI is advancing.
Right. Who knows what the future holds?
I know, it's exciting to think about.
It really is. Well, for our listeners who want to learn more,
Yes.
you can find the full paper, Cross-Decon V, Cross-Dimensional Transferable Knowledge Base via Fourier Shifting Operation, by Mehmet, Kanya-Vouz, and Yang in the show notes.
And let us know what you think.
Yeah, we'd love to hear your thoughts on the future of AI in healthcare.
Definitely.
Thanks for joining us on this deep dive, everyone.
Until next time.
Keep those neurons firing.